First 20 elements I gave you idea how to make, right? Understood or not? So first of all, you must write this one, electronic configuration KLMN. Accordingly, you have to draw the orbit and so proton, neutron and electron. This chart must be learned very carefully. Okay, ready? Good morning everybody. So today is the first day of pause, right? After some days we will say last day of pause, first day of mag, last day of mag, and we were born, life comes to the end, natural one, right? And this chapter also will be finished very soon. In today's class, we are discussing some new topics. What are they? New headings. What is first one? Valence shell. Please look at here, everyone. Make diagonal straight, and your mind should be present here. That's why I just said presence of mind. Look at in the smart board. We don't have here blackboard and whiteboard. Smart board. Smart students, smart teacher, smart school, smart board. First, what are we going to discuss? Valence shell. Second one, sound is not coming. What happened to you? Next one, valency. Right? Valence shell. Okay. What is first one? Valence shell. So, what is valence shell? The outermost electron shell. You can underline in the book, children. Amrit? The outermost electron shell of an atom that contains valence electron is called valence shell. Simply, the outermost orbit or shell of an atom. The outermost orbit or shell of an atom is called valence shell. So this is valence shell here. But if I draw here another atom, 6 proton, 6 neutron, 1, 2, 3, 4. So which one is valence shell? This one is valence shell or this one is valence shell? The outermost. This is VS. VS or valence shell. Is it clear? Children, is it clear or not valence shell? Okay. Now next thing. What is given here? Valence electron. We know the outermost shell is valence shell. Number of electrons present in the valence shell is called valence electron. How many electrons are present here? 1, 2, 3, 4, 5. So what is the valence electron here? 5. Now let's see in the chart. In the chart I will show you. Let's take some examples. Fluorine. Here is fluorine. In fluorine, electronic configuration is 27. Is here 27 or not? So what is the number of valence electron? 7. Here in 282, 2. 286, 288, 2882. Okay, then children, again you say me, when we see this one, lithium, KLMN, you just see here. What is the valence shell of lithium? Valence shell is L. Outermost shell is L. Pay attention, eh? Nitrogen? Nitrogen also L. Sodium? M. Sodium M. And carbon? N. That is valence shell. And number of electron is valence electron. Okay? Now this is also completed here. So one side is given. What is the valence shell of boron? Valence shell of boron? L. Shell is L and valence electron 3. Sodium, valence shell M, valence electron 1. Calcium, valence shell M, valence electron 2. Understood? Shell and electron. Okay, that is also completed. Now, what are we going to discuss here? Next heading. What is next one? Valency. Valence shell, outermost shell. Number of electrons present in valence shell. Valence electron. What is next one?
Valency.
Amrit Kumar. What is that? Pass me that. No. Valency. Here is the definition of valency. Children, look what I say here. The combining capacity of the number of atoms of an element with the number of atoms of other elements to form a molecule. Molecule contains two or more than two number of atoms, right? So how many atoms are combined to form molecule? That is the valency. For example, if I write here CO2, this is a molecule of carbon dioxide. Carbon dioxide. And here, how many oxygen atoms are here? Two oxygen atoms are here. Carbon, one. With one carbon, how many oxygens are combined? Two. So here it shows one carbon needs how many oxygen? Two. Next one, if I write here H2O, to make to form, means what is this? Water molecule. Two hydrogen atoms are required and one oxygen atom is required, right? In this connection, we have to see just opposite. Here is two. What is opposite of two? O. So valency of O is 2 and valency of H is how much? 1. Mainly we have to remember the valency of some elements, then it will be easy. For example, I just said valency of hydrogen is how much? 1. Oxygen is how much? 2. If oxygen is 2, then here 2. Oxygen 2 means 2 2s are how much? 4. So what is the valency of carbon? 4. It comes like that. Basically, we have to remember valency of hydrogen 1, valency of oxygen 2, and others we can find out. But again, question comes: oh, sir said 1, sir said 2. How? Now, one idea I will teach you. If that idea works, it will be very easy. How many electrons are given here? How many electrons are given here? 20. Right? 20 means at first you cross this helium, neon and argon. Why? They do not take part in chemical reaction. Helium, neon, argon, and there are other elements also, but we are discussing only 20. Right? Why they do not take? What is that? Keep that down. Muffler also give down. Why they do not take part in chemical reaction? Because their valence shell is full of electron. Valence shell does not need more electron. Why are biting the other others? Now, look at here. Hydrogen, how many valence electrons are here? Lithium, 1. Beryllium, boron, carbon. So, if at last there is 1, 2, 3, 4. Valency also 1, 2, 3, 4. Got the idea? Look at the valence electron. If valence electron is 1, valence is valence electron 2, valency 2. Valence electron 3, valence electron 4, 4. So now tell me, what is the valency of hydrogen? 1. Lithium, 1. Beryllium, boron, carbon, up to 4 is okay. Sodium, 1. Magnesium, aluminium, silicon, 1, 2, 3, 4. Is it okay? But if there is 5, 6, 7, then opposite. 5 means how much? 3. 6 means 2. 7 means 1. 5 means 3. 6 means 2. 7 means, and here 1, 2. Now you tell me valency of hydrogen. lithium, beryllium, boron, carbon, nitrogen, nitrogen 3. Nitrogen how much? 3. 5 plus 3. Oxygen, chlorine, sodium, magnesium, aluminium, silicon, phosphorus, 3. Sometimes 5, sometimes 3. Okay, sometimes 5, sometimes 3. Sulfur, 2. Sometimes 6 also. Chlorine, potassium, calcium. So, combining capacity of one atom of element with others atom to form a molecule. That is, what is that? Valency. Now see here. Here is the valency side. Hydrogen, lithium, boron, nitrogen, most of the time 3 or sometimes 5 also. Chlorine, sodium, aluminium, phosphorus, either 3 or 5 sometimes. Chlorine, potassium, helium, helium 0 I just said, neon by 0, argon by 0, beryllium, carbon, oxygen, magnesium, silicon, sulfur, 2, most of the time 2, sometimes 6 also. Argon, calcium, okay. So, here we have to remember their what? Valency also. First 20, this one. Now children, next heading is classification of elements. Elements, how do you define elements? Purest form of matter. What is the definition? Elements are the purest form of matter which are made up of only one type of atoms. Their atoms do not match with other. Gold atoms and silver metals, do they match? Iron and copper, do they match? Zinc and hydrogen, do they match? No, they are different. Okay, different. So, how many elements are known till now? 118. If we start reading all elements together, then it will be difficult or not? So, some elements they have got similar properties, some elements they have got different properties. For example, some elements are metal, some are non-metal. Metal means they are good conductor of heat and electricity. Non-metal means they are bad conductor of heat and electricity. Some we can hammer them, we can change it to plate like this one, right? Some metal if we hammer it breaks. I mean all elements they do not possess similar characteristics. Some similar, some different. On that basis they are kept in one table. What is that table called? Periodic table, that's right. What is it called? Who designed periodic table? Mendeleev. Who designed? Mendeleev. He was a Russian scientist. One Russian scientist, he made one chart and he kept the elements systematically. And Mendeleev is called father of periodic table. What is he called? Father of periodic table. So, why is he called father of periodic table? Because he gave the idea how to classify the elements, how to keep the elements inside. One thing you keep in mind, I already said all elements they do not have similar physical and chemical properties. According to the properties, if the elements are kept in a chart, that system is called classification of elements. What is it called? Classification of elements. That table is called periodic table. Table means chart. So one example of periodic table is here. Can you see your periodic table? You can see your periodic table. So actually it should be vertical, but here it looks horizontal but looks vertical. hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, sodium, magnesium, are they kept here? This idea was given by whom? Mendeleev. He gave that idea in 1869 AD. In which year? One thing remember, first iPhone and iPhone 16, do they have similar features or different features? Many different features are there, right? Size also differs, application differs, quality differs, right? So in the same way, Mendeleev made the periodic table for the first time, but there were some errors, and to overcome those errors, another scientist named Henry Moseley. What is the name? Henry Moseley. He made another table. That table is called modern periodic table. Now we have to keep in mind two persons. Mendeleev, his table, Mendel's or old periodic table, and Henry Moseley, new or modern periodic table. So Moseley, he studied the properties of elements and he kept those elements on the basis of their atomic number. On the basis of? Then what did Mendeleev do? How did he arrange? He arranged according to atomic weight or atomic mass. Mendeleev arranged the elements according to atomic mass or atomic weight, but Moseley arranged according to atomic number. Atomic number, Moseley; atomic mass, Mendeleev. Who became more successful? Henry Moseley. Henry Moseley, because there are very less errors in his periodic table. And next thing, while arranging the elements in the periodic table, Henry Moseley, he gave one law. He gave one law. What is that law called? Find out. That law is called modern periodic law. What is it called? Who gave modern periodic law? Henry Moseley. When? 1913 AD. Answer in pocket. Why? What is said or what is mentioned in modern periodic law? Here is this one. So changing. The physical and chemical properties of elements are the periodic functions of their atomic number. According to atomic number, if elements are arranged, then elements with similar physical properties and chemical properties will lie in same column or in same group. Actually, this is the periodic table propounded by Henry Moseley. Look at the book. Here is given 13, 14, 15, 16, 17, 18. Down 1, 2, 3, 4. Vertical, that is called group. What is it called? Top to bottom, group. Left to right, period. Top to bottom, group. Left to right, period. So these elements in same group, they have got similar physical and chemical properties. What is here? Boron. What is here? Aluminium. What is here? Gallium. So these elements, they have got similar physical and chemical properties. Like chlorine, bromine, iodine, they have got similar physical and chemical properties. But we need to remember. So, who gave this periodic table? All right. So, now children, what to remember here is that here is given group. In modern periodic table, there are altogether 18 groups. How many groups are there? 18. And how many periods are there? 7 periods. 18 groups and 7. Okay, I'll show you. N1, N2, N3, N4, N5, N6, N7. These are periods. What are they? Now, these are groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. What are these? Groups. Top to bottom, groups. Left to right, periods. So, who designed this? Henry Moseley. Right? Henry Moseley. So, our first 20 elements are here. What are they? See here. Hydrogen, group 1. Group 18, helium. Lithium, beryllium, boron, chlorine, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Right? Now the last portion we are going to discuss today is advantages of modern periodic table. What the first advantage? Okay. Hydrogen is kept in group 1. Where is it kept? Which has solved the issue of unclear position. Point number 2. Arranges the elements. Place elements like argon, potassium, right? Point number 3. Modern periodic table has 18 groups to make the study of more specific. And point number 4, also provides information on the electronic configuration of the elements. Okay, this helps to predict their chemical properties and behavior. These 4 importance we have to keep in mind, right? So next one is this is the modern periodic table. This is long form of modern periodic table. So some elements are kept down also. Are here some elements are there? You can see lanthanum, cerium, PR, ND, PM, something like that. These elements have again similar characteristics. They have got similar characteristics. Okay. So that much you have to study today. From where? Page number 267, 268, 69, 70, 71, 72. Will you read once again? Yes. Then be ready to get homework. I will give you homework. Okay? Reading time now. Okay.